Red dwarfs are the smallest, coolest, and dimmest of all hydrogen-burning stars, and they hold the record for the longest stellar lifespans in the entire cosmos. They will burn steadily for trillions upon trillions of years, far outliving every massive star, every sun-like star, and every white dwarf. By the time the last red dwarf finally fades, the universe will be so old that its current age of 13.8 billion years will feel like a single blink of an eye. Today, we are going to explore the extraordinary life story of red dwarfs, their quiet dominance in the Milky Way and beyond, the science that makes their extreme longevity possible, and their tragic gentle role as the very last stars to shine before the universe slips into eternal darkness. This is the untold epic of the cosmic survivors that will outweigh time itself. To understand red dwarfs, we first need to step back and look at how stars are born and how they live. All stars form from vast clouds of gas and dust, called nebulae, collapsing under gravity, until the core becomes hot and dense enough to ignite nuclear fusion. The key factor that determines a star's entire life, its color, brightness, lifespan, and final fate, is its mass. Mass is the single most important number in stellar astronomy. High-mass stars, those with 10, 20, or even 100 times the mass of the Sun, are the fireworks of the cosmos. They burn hydrogen at an astonishing rate, shining with a brilliant blue light, but they live fast and die young. A star, 20 times the Sun's mass, will run out of fuel in just a few million years, ending its life in a spectacular supernova explosion that can outshine an entire galaxy. These stars are dramatic, but they are fleeting. They are here, one cosmic moment, and gone the next. Sun-like stars, yellow G-type stars, like our home star, live much longer, around 10 billion years total. Our Sun is already middle-aged, about 4.6 billion years old, and in roughly 5 billion years, it will swell into a red giant, swallow the inner planets, and collapse into a small hot white dwarf that will slowly cool over trillions of years. But even this fate is brief compared to the life of a red dwarf. Red dwarfs are classified as M-type stars, the smallest and coolest stars that can sustain hydrogen fusion in their cores. They have just 7% to 50% of the Sun's mass, making them tiny by stellar standards. Their low mass changes everything about how they generate energy. In massive stars and Sun-like stars, fusion only happens in a small, dense core, and the energy travels outward through radiation. This creates a layered structure with a static core and an outer convective layer. For Sun-like stars, this means helium ash builds up in the core over time, and eventually, the star can't burn hydrogen efficiently anymore. But red dwarfs have a completely different internal structure. They are fully convective from core to surface. Imagine a pot of boiling water that circulates completely, mixing the hot water from the bottom with the cooler water on top. That is exactly what happens inside a red dwarf. Every drop of hydrogen in the star is constantly cycled down to the core, burned into helium, and mixed back up. There is no buildup of helium ash that chokes off the fusion process. This perfect mixing allows red dwarfs to use their hydrogen fuel with nearly 100% efficiency, something no other star can do. This efficient fuel use is the first reason red dwarfs live so long. The second reason is their slow fusion rate. Because they have low mass, their cores are not as hot or dense as those of bigger stars. Nuclear fusion proceeds at a gentle, steady pace, like a candle burning slowly instead of a bonfire raging out of control. A red dwarf emits only a tiny fraction of the light and heat of the Sun. Some are so dim that they give off more infrared radiation than visible light, making them hard to spot, even with powerful telescopes. But this dimness is their superpower. The less energy a star releases, the longer its fuel lasts. Let us put this into perspective. The smallest red dwarfs, with just 8% of the Sun's mass, have lifespans of 10 trillion years or more. Some of the most massive red dwarfs live for about 1 trillion years. To grasp how long that is, consider that the entire universe has only existed for 13.8 billion years so far. Every single red dwarf that has ever formed is still in its infancy. Not one red dwarf in the entire cosmos has died yet. Not a single one has run out of fuel or collapsed into a stellar remnant. They are all just getting started. For decades, astronomers overlooked red dwarfs because they are faint and hard to study. Early telescopes could barely detect their dim glow, and scientists focused on brighter, more dramatic stars. It wasn't until the 20th century with the development of more sensitive instruments and the Harvard Stellar Classification System, that astronomers realized just how common red dwarfs are. Today, we know that red dwarfs account for over 70% of all stars in the Milky Way galaxy. They are the most numerous stars by an enormous margin. If you could count every star in our galaxy, 7 out of 10 would be a red dwarf. They are scattered everywhere in the dense core of the galaxy, in the sparse outer halo, and in every spiral arm in between. They are the silent majority of the stellar world, quietly dominating the galaxy, while brighter stars steal the spotlight. The discovery of red dwarf abundance has changed our understanding of the universe's habitability. For a long time, astronomers thought red dwarfs were too dim and unstable to host habitable planets. Their habitable zones, the narrow range of distances where liquid water can exist on a planet's surface, are extremely close to the star. A planet in the habitable zone of a red dwarf would be so close that it would become tidally locked, meaning one side always faces the star, and the other always faces away. This was thought to create extreme weather with a scorching dayside and a frozen nightside, making life impossible. But recent observations by NASA's Kepler Space Telescope, TESS, and the James Webb Space Telescope have turned this idea on its head. We now know that red dwarfs often have quiet, stable stellar activity, and many have rocky planets in their habitable zones. The most famous example is Proxima Centauri, BA, rocky planet, orbiting Proxima Centauri, the closest star to the Sun, which is a red dwarf. The TRAPPIST-1 system, another red dwarf, hosts 7 Earth-sized planets, 3 of which lie in the habitable zone. These discoveries make red dwarfs the top targets in the search for extraterrestrial life. If life exists anywhere else in the universe, it is most likely orbiting a faint, long-lived red dwarf. But as incredible as their role in habitability is, the most awe-inspiring part of the red dwarf story is their place in the end of the universe. Let us fast forward to the distant future, far beyond the death of our Sunday. In 5 billion years, the Sun will become a red giant, then a white dwarf. In 100 billion years, most Sun-like stars will have met the same fate. In 1 trillion years, the last massive stars will have exploded as supernovae, leaving behind neutron stars and black holes. Star formation will slow to a halt as the universe runs out of cold gas clouds needed to birth new stars. The cosmos will grow dimmer, filled with cooling white dwarfs, dead neutron stars, and silent black holes. Galaxies will drift apart, stretched by dark energy, until they are no longer visible to one another. The universe will enter a dark age, with only the faint glow of cooling stellar remnants. But through all of this, the red dwarfs will keep burning. They will be the only sources of visible light in an increasingly dark universe. For trillions of years, they will shine steadily, a faint red beacon in the blackness. Civilizations that arise in this far future will look up at a sky filled with nothing but red dwarfs, unaware of the bright, diverse stars that once filled the cosmos. They will think red dwarfs are the only stars that ever existed. And then slowly, one by one, the red dwarfs will begin to die. Unlike bigger stars, they will not explode or swell into giants. Their low mass and steady fusion mean they will simply burn through their last hydrogen, gradually dimming over billions of years. They will contract and cool, turning from red dwarfs into white dwarfs, and then continue cooling until they become black dwarfs, cold, dark Earth-sized chunks of carbon and oxygen that emit no light or heat. The first black dwarfs will form in about 10 trillion years. The last red dwarfs will die after 100 trillion years. When that final red dwarf fades, the universe will have reached the end of the stellar era. There will be no more stars shining, no more light from nuclear fusion. The cosmos will be filled with black dwarfs, black holes, and cold gas, drifting in eternal darkness. The universe will be silent, cold, and still, a vast empty expanse where once there were trillions of stars. And red dwarfs will have been the last to hold back the dark, the final candles in the cosmic night. This story fills us with a profound sense of cosmic awe. We live in a special time when the universe is young and vibrant, filled with bright stars and colorful nebulae. We can see the full spectrum of stellar life, from massive blue stars to faint red dwarfs. We are here to witness the universe in its prime before the long dark age begins. Red dwarfs remind us that size and brightness do not equal importance. The quiet, unassuming things in the cosmos often hold the greatest power and the longest endurance. They teach us that patience and stability win the race of time, that slow and steady does not just win the race, it outlasts everything else. As we continue to explore the universe with telescopes like the James Webb Space Telescope, we will learn more about red dwarfs, their planets, and their role in the cosmic story. We will study their atmospheres, their stellar activity, and the worlds that orbit them. We will unlock more secrets of their extreme longevity and their place in the universe. Final chapter. Red dwarfs are not just stars, they are a testament to the universe's ability to persist, to keep shining, even when all else fades. They are the quiet heroes of the cosmos, the last lights to burn before time itself seems to stand still. Please like, comment, share, and subscribe to the channel.